We're going to be speaking about natural climate solutions this morning. And everyone knows that we're already experiencing warming, sea level rise, increased extreme weather, including precipitation, temperature, stream flows, etc. And these have all sorts of consequences for our natural infrastructure as well as our communities. And all of us, I know, are wondering, what can we do about these things? What can our organizations do about these things? And we want to be contributing to those solutions. So today, myself, Brendan Annett, Vice President of Buzzards Bay Coalition, based in New Bedford, Massachusetts, joined by Caitlin Chaffee, who's the manager of the Narragansett Bay National Estuarine Research Reserve, and Steve Long, who's the Director of Government Relations for the Nature Conservancy in Boston. We'll be putting together 3 presentations in a row for you that will give you an understanding of things that are happening here in Massachusetts and Rhode Island at the state level, projects that are being supported by both state and federal government, and projects that are being implemented by organizations locally. We are going to be talking about natural climate solutions. Technically, this term has come to mean protection, restoration, and improved management of land and water, specifically to increase carbon storage and to reduce greenhouse gas emissions. Today, we've decided to add to that activities related to managing, restoring, and protecting natural lands and waters that can help both human and natural communities to be more resilient and be better able to adapt to the impacts that we expect from climate change.
So I'm Steve Long, Director. I've been doing that job for 14 years. Great team. Emily Myron is our policy manager, and our relations team work with our conservation staff to help achieve the Conservancy's goals. And our mission is to conserve the lands and waters on which all life depends. So we're a science-based conservation organization. Advocacy is a very small part of what we do. We mainly inform and influence policymakers to help with funding and policy related to climate change, land and water conservation, and goals related to social equity. So today, I am going to focus on natural climate solutions, which we consider, and the Conservancy works on these in 3 areas. One, and these are our climate change strategies. Sorry about that. I'll give a little context, then we'll get to natural climate solutions. So we have several strategies in which the Conservancy works on climate change. So we all know climate change is exacerbated by emissions, greenhouse gas emissions. So the first and foremost and most important thing we can all do is work to reduce those emissions from the major sectors. And that involves also deploying renewable energy in the most environmentally preferable way possible. We're also focused on how we can optimize nature, how we can work with nature to draw carbon from the atmosphere. And that involves sequestration and carbon storage as well, maintaining the carbon stocks that are in the soil and vegetation. And finally, we're working on strategies to help strengthen resilience, nature-based solutions that help communities avoid costs, that enhance safety, and really strengthen our natural resources, the function of natural resources, to avoid and reduce flooding, drought, and heat. And one stat a lot of people don't know is heat is the #1 killer of climate change impacts. A lot of folks focus on flooding, whether it's coastal or riverine, but heat is really the major problem. So whenever we're trying to solve a problem, we need to look first at what's the situation. So in Massachusetts, our Executive Office of Energy and Environmental Affairs has done a deep analysis of where emissions are coming from. And there are a number of different ways to slice this. This way of looking at it is looking at where emissions come from households, whether it's transportation or buildings, that's the green, or business in blue. Transportation and buildings again, but different types of vehicles and a little bit of industrial. And then in the yellowish square, electricity generation. But another way to really think about that is transportation is the #1 source of greenhouse gas emissions in the Northeast, followed by electricity and then buildings. So a lot of states now are considering a goal of net zero emissions. It's a target that is twofold. One is reducing emissions to the maximum extent possible, and then the other piece is drawing carbon from the atmosphere using natural climate solutions or other technical means that haven't really come online yet because they lack the technical or economic feasibility. This graph here gives you a sense, sorry it's a little fuzzy, of the path to 2050 going across the bottom. And you can see the green sources of emissions being reduced, and then the blue at the top and the bottom at the very end are related to sequestration. So that's what net zero is all about. Massachusetts is one of 5 states that's adopted a net zero policy, and it's an emerging policy, so keep your eyes peeled in other states. The other states are Hawaii, California, New York, and I'm sorry, it's a jurisdiction, it's DC. So then we need to turn to sequestration. How are we going to fill those gaps at the bottom in blue? So one of the ways to do that is to think about forests. And when we think about forests, there are natural lands and there are working lands. So the natural lands are wildlands. These are forest reserves. These are parks where it's a light touch, such as recreation. And then we also need, and there's also wildlife habitat. But then we need to think about woodlands. These are working woodlands where there is timber harvesting or thinning to promote biodiversity or for foresters who have an economic gain. But we also need to think about trees in cities. Trees in cities provide multiple benefits. They reduce the heat island effect. They reduce the energy needed for heating and cooling when they're near a house. They also provide shade. They reduce pollution. And just in terms of the research that's been done more recently, there's a great benefit in having green space for mental health, especially during this pandemic when people have needed to get outside. So when we think about natural climate solutions, it's important to think about all those co-benefits, because if we lean in only on sequestration, it's not really a stable enough leg on which to make policy and funding and other decisions. So we really need to think about carbon natural climate solutions holistically. But we also need to think about how they relate to climate justice, which is a really important emerging issue. How do we make sure that investments are prioritized for environmental justice communities? How do we make sure that the residents of those communities have a voice early and often in decision-making about what's happening with natural climate solutions and other decisions that are being made? And how do we ensure accountability so those residents are continuously engaged? That's been a big gap in our environmental policy over time. So then we also need to think about where the carbon currently exists. And there was a fantastic phrase used by a Massachusetts state senator from Western Mass. She called Western Mass the lungs of New England. And this map here shows you their carbon-rich resources across New England. And you can see, surprisingly enough, even though Massachusetts is one of the most densely populated states in New England, we have some pretty rich carbon resources. And you can see the numbers here. The one thing that I think is really interesting is 7% of the emissions generated in Massachusetts are currently absorbed by Massachusetts forests. So the major law that frames climate change in Massachusetts is the Global Warming Solutions Act. That requires an 80% reduction from 1990 emissions levels by the year 2050. And that was changed with net zero. Now the goal is net zero by 2050. So under the Global Warming Solutions Act, as it's written, only the emissions from nature are counted. Sequestration and storage are not counted. Our goal is to count both, to establish a baseline, to have goals for sequestration, and to have a plan in place and policy and funding. And I'll get to that in a moment. So just a quick review of current policies. There's a very robust smart growth program in Massachusetts. It's voluntary. It encourages the adoption of municipal bylaws, such as natural resource protection zoning and tree retention and planting for an attempt at a no net loss approach. The Mass Environmental Policy Act also has thresholds regarding tree loss. The Regional Greenhouse Gas Initiative, which covers multiple states, has forest offsets for afforestation, planting new trees, but as far as I know, that's never been used. Another current existing policy in Massachusetts is the Greening Gateway Cities program. This program was established, and I see my friend Linda Orell in the audience. She was very instrumental in getting this program established through a bond authorization. And the justification was something I'd mentioned earlier, trees being planted near people's homes with providing energy savings. And this program is really cool because it provides workforce development in urban tree planting. So our state agencies work with local nonprofits to identify residents who need job opportunities. Those residents get trained and certified in tree planting, and then they can move on to jobs in the future. And so far, about 26,000 trees have been planted in our gateway cities, and those are cities that are the old mill towns that are still in recovery. So over the past 2 years, the Executive Office of Energy and Environmental Affairs has been doing this extensive effort to look at how we decarbonize. And I'll get into the process by which they've been doing that in a moment, but it really depends on 4 major sectors, 4 major initiatives: increasing energy efficiency, switching fuels. So for cars and for homes, that means getting off fossil fuels and moving to electricity that's powered by renewables, increasing the deployment of renewable energy, and increasing carbon sequestration. So this has been quite an extensive process. The Commonwealth hired consultants and produced a decarbonization roadmap study that was published in December 2020. This was based on an approach that included scenario planning. So the researchers forecast what the energy demand would be in Massachusetts under a number of different scenarios, looking at population, demographics, economics, a whole wide range of things. They looked at 8 different pathways about what Massachusetts might look like in 2050, and they plugged in the best ways to reduce emissions. What are the pathways we need to reduce greenhouse gas emissions during that time? Based on that study, the roadmap points to the biggest investments we need to make between now and 2050. In the short term, the Global Warming Solutions Act requires that a plan be published every 10 years. And this plan was also published in December 2020, the 2030 Clean Energy and Climate Plan. And that plan was informed by 5 work groups of the Implementation Advisory Committee, which is the Climate Council run by the state. And I worked with Linda and others, and I chaired what we called the Land Use and Nature-Based Solutions Work Group. And we provided recommendations and advice to the Executive Office of Energy and Environmental Affairs about the best ways to sequester carbon and maintain stocks. So we had recommendations in 7 categories. You can see them here. Basically, we were looking for the best ways to protect, manage, and restore natural and working lands. So that included land protection and the avoided forest conversion recommendations. It included looking at blue carbon, the wetlands and salt marshes, urban trees. We wanted to place a value on forest carbon, so we had a no net loss approach. Improved forest management, and then looking at soils and looking at what municipalities could do. So it's quite a lengthy set of recommendations, and you can find those on the EEA website. There was a joint memo prepared by all the 5 working groups, and each of the 4 working groups collaborated with the Climate Justice Working Group to be sure that we were consistent with the principles of environmental justice. So what does this plan look like? There's basically 4 strategies in the plan. One is to protect natural and working lands. So the Commonwealth is working to achieve a no net loss of forests and farms. They have a suite of incentives that exist and will be enhanced, and new incentives they're considering. Our working group is recommending that they put some more teeth behind those recommendations and have some regulatory requirements. This strategy also looks at protecting and restoring inland and coastal wetlands, the blue carbon resources. And again, it's very incentive-based, so we're looking at increasing regulatory strength and funding and technical assistance for cities and towns on things like stormwater, wastewater, septic, because nutrient pollution is one of the main reasons that salt marshes and wetlands are being degraded and not able to sequester carbon and releasing storage. Another piece that was emphasized in the plan is ecosystem management. So better management of soils, better management of forests. How do we approach this? This has become a real hot button issue in Massachusetts, with either extremes of foresters who want to retain their way of life and economic value of doing forestry, versus some segments of the environmental community who believe there should be absolutely no cutting of trees. So this process that we went through did not reconcile those differences. Our working group was pretty tightly reined in by the executive office answering specific questions. But I think this is a big issue that really needs to be addressed in the future. And it needs to be done by a facilitator and perhaps by the environmental agencies. But it's not appropriate for NGO stakeholders who have vested interest to try to navigate those waters. We tried, and it didn't work. So there's also a strategy on incentivizing the use of sustainably harvested and managed wood to put it into wood products. And one of the big pushes is to develop wood products from a lot of the timbering that's left over, that would be left over in the forest. There's cross-laminated timber, which is like very high-tech plywood that can be used in structural applications. And then New England Forestry Foundation is the leader in that area. There's also a push to develop sequestration accounting and market frameworks. So the Executive Office of Energy and Environmental Affairs is working with other states to figure out how those states can collaborate, and the states that are more carbon rich can help states that are not so carbon rich work toward achieving net zero emissions. And you remember before I showed you that Massachusetts forests absorb 7% of the carbon we generate through fossil fuel use. That leaves a big gap. So what do we do about that? How do we avoid unintended consequences of letting polluters off the hook? How do we avoid the unintended consequence of leakage or additionality, where we want to be sure that activities are going beyond business as usual in Massachusetts, and we're not doing the best job in Massachusetts before we try to do things out of state. The Commonwealth is also calling for convening an interagency task force. We're saying that needs to be stakeholders, and the Commonwealth also intends to update the sorry, the emissions inventory. I'll just cover these super quickly. I feel like I'm talking too much, but there were two other initiatives going on in parallel in Massachusetts: the Resilient Lands Initiative, which was a robust stakeholder process. There was a focus on natural carbon storage and climate resilience, and the big push out of the Resilient Lands Initiative was a no net loss of farms and forests, which got translated into the Clean Energy and Climate Plan. There was also a Healthy Soils Initiative going on at the same time, so folks were busy, and there were several recommendations related to the management and protection of healthy soils, and those are also getting woven into the Clean Energy and Climate Plan. At the same time, you think we weren't busy enough with all these stakeholder groups going on. Legislation has been moving through the State House, and in fact, just yesterday, this legislation was sent to the governor's desk. And because EEA, the state was a little slow in moving forward on carbon sequestration and storage to our satisfaction, there was a coalition of groups, NGOs, conservation NGOs that worked to get some language in the legislation that would require the state to conduct a baseline assessment of carbon sequestration and storage, to set a goal for both sequestration and storage, and then to develop a statewide plan to achieve those goals. We felt that the Clean Energy and Climate Plan was a good start, but it needs to be enhanced and rounded out. We also called for a robust stakeholder process, and that the process and the planning to come out with a set of recommended actions, and then a call for natural climate pollutions to be better integrated into the law. So I will pass it on now to Caitlin. Thanks for bearing with all that content, and I appreciate your attention. Thank you.
Great. Thanks, Steve. That was great. Thanks for such a great introduction of the topic. And a big thanks to Brendan for inviting me to join you all today. I'm going to go ahead and share my screen, my file here. And just introduce myself. I'm the reserve manager at the Narragansett Bay National Estuarine Research Reserve. So I'm going to start with a little introduction to the reserve system. I want to make sure, I'm sure many of you are familiar with the research reserve system, but I want to make sure that you're aware of what we do and the resources that are out there. I'm still trying to share my file here. And then I'm going to talk a little bit, as Brendan said, we decided to include the resilience piece in the natural climate solutions topic. So that is really what I'm going to focus on. All right, I'm going to go ahead and try to share my screen because the share file doesn't seem to be working here. Let's see if I can do that. All right, are you able to see my screen?
Not yet.
Not me.
Okay.
Bear with it. It seems to be taking time. Also, for the audience, what we've been told by Matt was that the audio problems were associated with the screen sharing. So hopefully once the file is up, the audio problems cleared. At least they did for me. I have your file and could bring it up. You'd have to tell me how to advance slides.
Sure, if you want to try that. It doesn't seem to be working from my end. I tried the screen share as well, and that didn't seem to work.
Maybe I need to do something. Did I stop sharing?
Oh, you might need to stop sharing, Steve. Just hit the icon again. No, but I think because we see all of us, you must have stopped. Yeah.
Yeah. Huh.
All right, I clicked it, so let's see if it comes up.
Okay.
All right, just give me a wink when you want to advance.
Okay, that's great. Thanks, Brendan, and thanks for your patience, everybody. Again, I'm Caitlin Chaffee, Reserve Manager at the Narragansett Bay National Estuarine Research Reserve. I'm pretty new to that position. I came on in September I previously worked for the Rhode Island Coastal Resources Management Council, which is our state coastal zone management agency. Go ahead and advance. Thanks. So just a little bit about the Narragansett Bay NER. We are a state-federal partnership between NOAA. So like the coastal zone management agencies, the research reserves were established under the Coastal Zone Management Act. So most of them are state-federal partnerships. The Narragansett Reserve is headquartered on Prudence Island. And so please come visit us if you're ever in the neighborhood. Our work is really divided into 4 sectors: research, training, education, and stewardship, that work very closely together. And climate resilience is absolutely at the forefront of what we do. We're lucky to be part of a national network. So there are 29, soon to be 30 research reserves nationwide. So just for those who might be new to this arena, wanted to make sure you get to know your NER. We're fortunate to have 4 in New England, and there'll be a new research reserve coming online in Connecticut soon. And so I've just listed them here, but it's wonderful to be part of this national network. It kind of puts our work in context. It means that there's a lot of collaborative research and work that happens. And again, climate resilience is at the forefront of all of that. Next slide.
Duck.
Oh no. Okay.
Oh no. In advance.
I can continue to talk. You know, unfortunately, we may not have the visuals, but I'm advancing my slides on my other screen over here. So if folks don't mind the sound of my voice, I can just continue to talk, and then if it pops back on, we can just go to the slide I'm on. I did want to mention, you know, all the reserves. There's also a NERS science collaborative, you know, that's literally science to support coastal decision making. And so that's a great resource there. You know, you can find them online. Links to all of the projects that come out of the science collaborative. And again, those are projects that are being done by multiple reserves. There's webinars, lots of resources there for land conservation organizations. And I think the focus, again, is really on user-driven science. So there's a lot of needs assessment that goes on to really hone in on the needs of coastal managers, land managers, so the science can be directed to important issues. We're also, you know, all the reserves are plugged into NOAA, so there are resources that NOAA makes available through its Digital Coast page. Again, you can kind of just Google these things. I've got links and can make my presentation available to whoever's interested. But there, you know, the Digital Coast has sea level rise maps and data, different kinds of tools. There's all kinds of trainings that happen through Digital Coast. And then at the state level, we're fortunate to have even higher resolution localized data. So I know for Rhode Island, the Coastal Resources Management Council has developed storm tools, which is high resolution sea level rise mapping. There's several tools that are kind of fit within the storm tools umbrella. We've got shoreline change maps that look at coastal erosion, sea level affecting marshes model maps that looks at marsh migration. There's a coastal environmental risk index map. So all of these are available under kind of that same storm tools heading and available to the public. And I know there are similar maps available through the Massachusetts Storm Smart Coast Initiative. So this is the kind of information that we use when thinking about coastal resilience, climate resilience in terms of natural shoreline features. And what I was going to focus on today it was the piece of resilience and thinking about natural shoreline features and the role that they play in climate resilience. And so really in Rhode Island for us, that means fringing salt marshes and low-lying coastal uplands, vegetated banks and buffers, dunes, those kinds of natural features, and then coastal wetland complexes. So these areas that provide multiple benefits, mitigation of flooding and erosion, storm surge protection, and also that important carbon storage function that Steve was talking about. And then, the other thing that's important to note is that preservation of these shoreline areas redirects development away from hazard-prone areas. And so the preservation and conservation piece is also very important. We've recently, before I came over to the NERS, I was working with CRMC, and we obtained a National Fish and Wildlife Coastal Resilience Fund grant to do some work on shoreline adaptation for climate change. And so that was a partnership between CRMC, URI, Coastal Resources Center, and Sea Grant Program, Save the Bay, and Roger Williams University. And basically, we wanted to kind of create a program that could queue up projects for these multiple sources of coastal resilience funding that are starting to emerge, things like the Federal Coastal Resilience Fund. And so really the first piece of the effort was to create an inventory of potential projects. And this was done in close coordination with municipalities for the most part. So we did outreach to all 21 coastal cities and towns in Rhode Island to work with them to prioritize coastal resilience projects. Worked with state agencies, really focusing on public shoreline areas. And what we're defining as shoreline adaptation projects. So these are projects that have multiple benefits but occur on the shoreline. They look to increase public safety, natural habitat, preserve public shoreline access, provide for water quality improvement, and shoreline protection against flooding and sea level rise and erosion. And so we have an online map that you can access. Right now it's kind of in the form of a Google map where you can go in and see the projects that have been identified, broken out by those categories, by categories. And if you click on each project, you can get a little bit of information about where it is and what the proposed activity would be there. And so I have pictures of these, but I'll just kind of run through the types of projects that we're considering. So things like pavement removal, so street ends that dead end at the shoreline. So these projects usually involve kind of pulling back pavement, removing hardened structures, and restoring whether it's fringing marsh or just natural coastal upland vegetation, pulling back infrastructure that's usually degraded and the municipality wouldn't want to maintain. And so you're both increasing the natural habitat and removing a kind of a maintenance and safety burden. Some of them involve stormwater management, so implementing green infrastructure practices close to the shoreline to prevent upland stormwater impacts, things like bioretention, structure removal, so derelict structures, things like boardwalks, buildings that can be removed to allow for more green space at that shoreline interface. A lot of times this will involve regrading of slopes to make them more dissipative, to minimize erosion. And then natural feature restoration can encompass many things. There have been a lot of dune restorations. Certainly fringing marsh and coastal wetlands would be a part of that. So reestablishing those areas either by planting or restricting vehicular access so that they can regenerate on their own. And kind of tied to that would be road relocation or limiting vehicle access. So in areas where there's parking allowed on sensitive coastal or shoreline habitats like dunes, you would restrict that access and provide for parking elsewhere. So we've had some projects that have sought to do that. Bank regrading and stabilization, so where you have severe erosion on vegetated banks, using natural solutions instead of revetments and hardened structures to stabilize banks. Often these involve biodegradable materials like core logs or core envelopes, but always vegetation is involved. A lot of times they involve regrading, again, to create more dissipative slopes to minimize erosion. And so there have been several of those projects. We have, I feel like there's a growing suite of professionals who are familiar with those kinds of methodologies. And so the goal would be kind of to increase that cadre of professionals. We worked on a project with the Nature Conservancy at Rose Larissa Park in East Providence, which was really truly a living shoreline project. Part of it was marsh replanting and creating a fringe salt marsh behind an intertidal sill, and then some natural bank stabilization. And the other example I just wanted to touch on briefly is the piece on coastal wetland resilience. And so because of a large part and because of the science that's been done at the research reserve, we know that our high marsh habitats in particular are declining in Rhode Island, and we're seeing impacts from accelerated sea level rise. So we're seeing marshes that are subsiding, increasingly flooded, ponded water on the surface that's killing off vegetation, that's kind of creating these negative feedback loops where larger portions of the marsh are dying off, increased erosion. And so we're looking at ways to stem those impacts. One particularly innovative approach is to fortify the marsh with sediment to create elevation capital. And so we've implemented a few projects, most notably when I was at CRMC, we were involved in a couple of projects down on the Rhode Island South Shore in the coastal ponds that literally pumped sediment onto the marsh surface, in many cases in areas where vegetation had completely died off, and then replanted those areas and let them recolonize naturally to build surface elevation. So really, the idea is to build marsh elevation capital, but also because this is a relatively new technique in New England and not really permittable, I know in Massachusetts, we wanted to conduct rigorous monitoring to be able to evaluate the effectiveness of the method and share the results and lessons learned. So for anyone who's interested in that particular technique, we do tours all the time of our project sites. Save the Bay is on site usually during the field season, and has worked to do adaptive management and maintenance of these projects. And so we're happy to share the information that we have. We'll be publishing, hopefully, a paper on the Ninigret Pond project. We're looking at possibly this fall. And so, and there are opportunities for volunteer involvement, community involvement. There's huge planting efforts that are related to those projects. And so, for anyone who is interested in learning more about them, please feel free to reach out to me. The point is to kind of share what we've learned. And I'm sorry I can't show you the pictures associated with the projects, but the results we're seeing are pretty dramatic. We've seen really good rates of revegetation in both the Ninigret and Quanaketag projects that we've done. And where we can, we're trying to couple improved public access with these projects. So we've done dune restorations and beach restorations where we've had the sediment to do so, and that's kind of enhanced public access along with habitat condition. And so with that, I wanted to be sure to give a shameless plug for my friends who are later today giving a session on salt marsh ecosystems and climate change adaptation. So there's a session at 1:45, Save the Bay, the URI Environmental Data Center, the Massachusetts Office of Coastal Zone Management, and Mass Audubon will be presenting on some other marsh resilience techniques that have been employed in Rhode Island and Massachusetts. So wanted to encourage everybody to check out that presentation. And that's all I had, and I'm really sorry that there are no visuals. But please, please feel free to contact me if any of this piques your interest and you'd like to find out more. I can certainly share my PowerPoint with anyone who's interested.
Thank you, Caitlin, and great job for working through that. I'm actually going to hang up. I didn't do it and come back as fast as possible. I didn't do it while you were talking. I was worried it was going to disturb, but. Just come back if something happens, but hopefully I can check out and come right back. Ooh, it may have worked. I was worried because I have this broadcast button that was going to crash the whole thing if I did that while you were talking, Caitlin.
No worries.
Matt, are you still with us?
Yeah, my camera isn't working anymore for some reason,
Okay.
but I am here. um,
See if my share
yeah.
screen comes up. All right. Maybe do what you did, Caitlin, and open my slides and run through them separately. Oh, it worked.
Okay, and they're up.
Amazing. All right, thanks for hanging in there with us, people. Okay, I'm going to get right to it. I'm Brendan Annett, Vice President of Watershed Protection at Buzzards Bay Coalition. Buzzards Bay Coalition is a regional conservation organization based in New Bedford with offices in Woods Hole and Marion and Onset. It's been around for about 30 years. We have 11,000 members from the towns around the bay. A number of years ago, because of the way hydrographically water pumps in between the holes of Woods Hole, Quicks Hole, Robinson's Hole, all the openings in the Elizabeth Island, and water is exchanged with Vineyard Sound, we've included that in our focus area. So our area is really from Little Compton, Rhode Island at Takana Point up to the head of the watershed in the Plymouth area, and then down to Falmouth and the Elizabeth Islands and to Gay Head. I put our mission statement there because while, yes, we're a conservation organization, we're very much oriented towards use and enjoyment of this resource that's so important to these communities around us. But I think the important word that's always been in there from the beginning is sustainable, and that's very relevant to what we're talking about today. Since the beginning, we've been very science-oriented. Not surprising, we evolved out of sort of a group of founders that actually included many scientists in the scientific community in Woods Hole on the eastern side of the bay. But for about 30 years, I think actually next year is our 30th year, the foundation of our whole program is based on what has now become the largest volunteer-led or volunteer-run water quality monitoring program in a coastal environment in New England. And here's some sort of stats about that. My point being is that we've always had sort of a foundation in understanding the condition of the natural resource we're concerned about, where it's at, and how it's changing over time. In recent decades, we've created this State of the Bay report, which basically takes the information from that monitoring program and other monitoring, including, very importantly to what we're going to talk about, forest and wetland land coverages with GIS analysis, as well as stream disturbances, and create this State of the Bay score. That number is a little bit discouraging, but our efforts are entirely driven to try to drive that number up. Our programs focus on basically policies that are protective of the waters of the bay, particularly pollution contributed to the bay, which is what we consider the main threat to the bay resources is the change, basically conversion of land uses that results in pollution, primarily nutrient pollution to the bay. Because of that, about 20 years ago, we evolved a watershed lands program and have evolved into an accredited land trust at a regional scale and have a very active land conservation program and disturbed lands restoration program. And then more recently, I think it became apparent that we can't do any of this if we're not making sure that people are engaged. Meaning, if the next generation doesn't care, then none of what we're doing really matters. So we've developed programming that's less about environmental education and more about getting people interested and in love with the natural aspects of this wonderful place where they live or work or spend time. We're very strategic oriented. That evolves out of that scientific sort of foundation. I'm now talking about land protection. We have this large very large watershed area, obviously, and it's very diverse, can't protect all of that land, but we use GIS based on, and are really focusing our land protection, or have focused our land protection on protecting water resources, aquatic and marine habitats, so a very water-oriented approach. You can see sort of our priority areas identified here, sort of along coastal embayments and along the major river corridors of the bay. I use this slide to segue into what we're talking about today, because 15 years ago, a lot of people talking about climate change. It came up at our board meetings regularly. The thought was, what can we do about this global problem here locally? And the board and staff struggled with that. But eventually, as we got into the last update of the strategic plan, we decided that there were things, particularly from a land protection perspective, we're certainly also sort of trying to reduce our emissions. We've added solar to all our buildings, which now covers just about all of our electricity use, and offsets our carbon emissions. But we wanted to be more deliberate and strategic in how we protect land from a climate perspective. Of course, when we're interested and concerned about water resources, aquatic habitats, protecting forests and wetland habitats, meaning coastal wetlands or wetlands in the freshwater portions of the watershed and forests well up into the watershed, this is really what has driven our land protection program the whole time, because those habitats are so valuable for the ecosystem services they provide for basically intercepting, removing nutrient pollution. But of course, that crosses over to when we start to think about carbon. All of what you're looking at there is active photosynthesis and storage of carbon, both in the plant material themselves and the soils underneath that. So I'm going to give a few examples of land protection and restoration projects that we've advanced that really have sort of climate drivers behind them. I'm going to start with this. Buzzards Bay is southern New England, just like all of us, I guess. Historically, this is an eastern brook trout, and this is actually a salter brook trout. That's a variant that lives in a coastal stream, has access to salt water. Some of them move out to salt water, grow much bigger, and then come back to freshwater habitats like this to spawn. They require cold, clean water in these coastal streams, and they've been very disturbed throughout their range, previously extended down to about New York City. Now, Massachusetts and Rhode Island really only have a handful of these populations remaining, where previously they existed in every little stream and rivulet. My understanding is there are some remaining in little springs on Prudence Island. I've heard that from Kenny, Caitlin. But mostly where we find these, they're single streams, isolated populations. And I showed this as sort of the saltwater habitat that they move into. But in Westport, Massachusetts, that's the estuary we were just looking at, there are more than a half dozen stream systems that still have individual populations. So connecting the dots here, this is a temperature-limited species at the southern end of its range. It is very threatened by change in temperature as well as disturbance to habitat. So there's something unique about protecting sort of this as sort of a resource that we don't want to expire. But in this location, there's sort of a technical ecological resilience approach here, because each of these individual streams hosts an genetically unique population. What that means is that together this creates a more diverse metapopulation, which is better able to sort of evolve traits and genes that help the overall population to adapt over time. It also enables a situation which you can envision and has happened elsewhere in Massachusetts, where individual populations and individual streams expire because of disturbance to habitat, that you have that it's not, that population's not alone and then long gone, but you have adjacent populations that can actually help to repopulate these individual streams. So because of this unique situation in this estuary, we decided to add land protection around these unique streams as a focus area in this last strategic plan. Just to show you how that would work, I mean, you're basically, this map is identifying the a distance from the stream, overlaying that with private parcels. The purple actually is not just the stream corridors themselves, but the wetland complexes associated with those streams and a buffer with them. And then we just start files and we start reaching out to those landowners. Over time, that means putting together, this is how land protection works in our sort of broken up land ownership pattern that we have. Over time, we've been able to piece together and augment existing protected lands and add through a dozen plus projects hundreds of acres to protection on these streams. This is just an example of Angeline Brook, one of those streams. This, of course, each of these projects ends up being a land conservation project, just like each one of your organizations is always juggling and advancing. We're just doing these in a strategic way and doing them in a coordinated way so that we can put together this stream corridor. Going back to that sort of estuarine environment from the air, you can, you look at this and say, oh, well, there's some climate problems, sea level rise and threats to some of that infrastructure, threats to those coastal barrier beach habitats. But as Caitlin was talking about, if you look in the estuary, you see the, I don't know if you can see my cursor, you see the islands of salt marsh that are in the estuary. We're losing those rapidly, as Caitlin and Steve brought up. It's sea level rise, and it's actually exacerbated by the nutrient pollution that we're fighting. And in places where we have low elevation, low gradient natural land behind or up gradient of the salt marsh, we have places where over time as sea level rises, these salt marshes can move up gradient. In some places where you have heavy development, infrastructure or private property, that's all going to be protected in the future. So we want to protect these remaining open areas like this that offer places basically for Buzzards Bay's salt marshes of the future. I pulled this off the internet. I think it's just a really easy way to sort of think about this. You have the salt marsh, you have higher and higher tides over years, decades, begin to change the vegetation, not only in the high marsh, but in the buffering upland adjacent to it, and you're creating areas where the high marsh can move into, albeit, you're converting some upland habitat. But if you have a seawall or houses or infrastructure or property that needs to be protected, you don't have opportunities for that. So here's an example of how we did that, where we did that. So in Massachusetts, the Biomap 2, which was updated, 10 years ago or so, actually identified these areas. They call them, it's this light purple at the bottom, they call it upland buffer adjacent to existing coastal habitat. And so you can see these areas adjacent to the salt marshes. And so we added those to our priority protection areas when we updated our strategic plan. Here's an example of where one of those areas is. This is Aquoot Cove in Mattapoisett, or this is Aquoot Cove. This is Mattapoisett Harbor. So this is Pine Island Pond, is a small estuary here. The parcel in question, privately owned, is about 120 acres, but fell within this area that had been identified because of this. Not only is it adjacent to protected land that we have been working on, but it falls within this area of coastal habitat migration. Just to help all of you, over time, the Nature Conservancy more recently has created a resiliency data layer, which is very helpful. It's actually very similar, but has a little bit more detail. You can see how it's broken up in terms of sort of risk of expected sea level rise. But it shows the same thing. And this can help you identify these parcels, and it can also help you to build the case for why you need to protect them. Other data layers, and I'm doing this deliberately, showing you different things that you can pull from. So this is not specific to coastal marsh migration, but it's related. In this case, it has to do with coastal hazard risk. So these are FEMA maps that show areas of inundation or expected inundation and inundation risk. So again, you can see that overlap on that blue parcel. The scale is going to change, but it's the same parcel. This is hurricane surge scenario. I believe this comes from a NOAA data layer that's available to everybody. But again, you can see sort of how it highlights these parcels. And then I think this also comes from NOAA. This is, and through the coastal program. So this is basically a sea level rise modeling. And again, you can see that the parcel is highlighted. So after showing you those, I wanted to show you sort of what this parcel looks like from the air. And you can see the salt marsh behind the estuary with the large protected land, which is our existing protected land, but then this upland area that had been privately owned. And you can see why we would focus on protecting that. Here's looking basically from this tributary stream, which you can see is actually somewhat tidal during higher tides because of that open area with the forested. The forest doesn't come to the edge. That's tidal marsh extending up, and we would expect that to expand laterally and up gradient over time. So in this case, this was a great. This is just a great example, and this was the first land protection project in Massachusetts that was funded by the new municipal vulnerability preparedness program. So in this case, the land is owned by the Mattapoisett Land Trust, and the town of Mattapoisett, which received the grant, and Buzzards Bay Coalition jointly co-hold the conservation restriction over this property. Now switching to restoration, this is up the bay a little bit. This is again at head of tide on a larger river. This is the Weweantic River. Actually, if you look in top left, that's the bay in the distance in the mouth of the river. But this is the head of tide. You can actually see it's low tide. There's tidal flats exposed. These are tidal wetlands and flats, coastal habitats. In this case, same thing, focused land protection program along and adjacent to the river resource, both for floodplain protection, ecological resilience, and coastal in this case. In this case, right in the center right, there's actually a dam. So this property had a dam at head of tide. In this case, we pulled together some funding that was associated with penalty money from the oil spill in Buzzards Bay, hired an engineering firm to do the monitoring and develop the design for removing the dam. Here's a picture of the dam from a drone above it, upstream. In this case, there's a big advantage of actually, you can think about it based on what we were just talking about with the land protection in Mattapoisett. This concrete wall is blocking tides from extending and all the estuarine organisms from expanding further, and not just, blue crab and shrimp and menhaden and fish, but actually even tidal vegetation. So there's down in the saltier portions of the estuary, it's dominated by what we think of as salt marsh vegetation. In these higher freshwater tidal areas, there's different types of vegetation, different emergent grasses that create very valuable and have become rare habitats because these locations are often disturbed because of dams or transportation corridors. But opening this up, rather than having that be a freshwater pond up above the dam with a big wall in front of it, this is an area for coastal habitats to adapt into and to migrate into. So there's the design, there's our old dam. Of course, the exciting day finally comes. This is very fun, although it actually is a much more controlled process than what that previous picture suggests. Lots of permitting, probably a dozen different local, state, and federal permits to do this type of work in the water. Here's another picture from a drone above. You can see the dam, and then the river opened up to the tide. Here's the impoundment just prior. And then the impoundment just after, you can see the stream channel sort of trying to find itself. That's about a year ago, just a month after we opened it up. By last summer, the stream channel finds itself, the emergent vegetation is reestablishing, and we have sort of made huge jump in supporting the migratory fish that exist in this river, but also opening up sort of this large area to migration of coastal habitat. Lastly, in a much more developed area, so this is urban north end of New Bedford, looking south down the estuary of the Acushnet River, which is New Bedford Harbor. I'm going to focus in on the lower right-hand side. So this is at the head of tide on the Acushnet River. There had long been this industrial facility, which is the Acushnet Sawmills Company, so an industrial sawmill company. By around 2007, we decided to buy the property. It was no longer an active sawmill, but it was still the industrial site. So adjacent to the estuary at the head of tide, all this 20-acre property, probably 3 to 4 acres of pavement, tens of thousands of square feet of buildings. Here's a picture of what it looks like from a drone. You know, we like these drone pictures. I like how this one matches up with the following. The idea here was, because of the unique location ecologically, head of tide on the estuary again, and because of its unique location to the community adjacent to it, meaning there's thousands of people that can walk to this site from their homes on the sidewalk, we wanted to restore ecological functions, but also really open this up as a green space for the urban community. So the vision was to turn this, you see the river on the right-hand side, into what our landscape architect interpreted as this. And these are all from the same location. Again, we did a pretty good job. This is the outcome. So what this meant was a lot of money. We raised quite a bit of money through a variety of grants. A lot of engineering, although the engineering is primarily, the work is primarily banging down buildings and pulling up pavement, but there is a lot to do with regrading the surface of the ground and to create wetland habitats and restore streams, restore the stream habitat, stream bank habitat. We engaged a lot of people by doing this because it's adjacent to a pretty dense residential community. Which was really great and led to the property being very well taken care of by the community after it was done. There was a dam at this site as well. After it was removed, it looks quite different. When we started, there's these concrete walls in the stream, bridges over the river, buildings all over the place, concrete and pavement all over the place. Same location after, looks like this. And my favorite picture right here is the entrance to the site. The river is actually in the middle of that picture underneath the concrete. Those buildings straight ahead are on the other side of the river. And this at the same location. You can even match up some of the trees in the background when we were done. And then looking from the back of the site out here where we have a place that was inside a building, now actually a functioning wetland. Part of the floodplain of the river. Here's a great fall view of the site from overhead that's similar to the historic picture that I showed before. We added some trails, some overlooks on the river, some interpretive panels. Again, when the site starts, what used to be pavement and indoors now holds floodwater like this and serves as habitat like this, you might have done something right. When this many people are smiling, you know you've done something right. So that's one of the great things, and one of the reasons I add that to this presentation is sort of engaging people ends up being an important part of this. So what are the things that we can accomplish by doing this? I think the first one is, right, all that we do, protecting and restoring natural habitats. We're allowing photosynthesis to happen, preserving those plants and habitats that basically are storing carbon in the plants and in the soils. We offer shade for streams, for fish, for people. It's all important. There's a safety component here, as Caitlin explained, certainly with flooding and both coastal and river oriented. There's cost avoidance for preventing development that needs to be protected in the future as these risks increase. Certainly habitat restoration, ecological community resiliency, both to allow organisms and communities to move, as well as to hold them together, as I was talking about with preserving the genetic diversity in the multiple streams. And then, of course, the public access and engagement, Caitlin also mentioned, is hugely important, because in the end, these little projects are really just a demonstration or proof of concept. We're handing off a pretty difficult problem to this group of people, and I think it's important for us to show them that that there are ways to address some of these problems, even if we're starting small, and that there is hope for making some big change here. So with that, I'll wrap it up, and we can see if we have any questions from you.
So Brendan, my job was to keep an eye on the Q&A, and I do see a couple of questions, but first I'm going to put links to some Massachusetts resources in the Q&A. So there's two links. There's one to all the reports and analysis and the plan that the state produced, and then also there's a link to the recommendations from the working groups that were informing the planning process, so people can check those out. So we have one question, and forgive my pronunciation on names. Dave Deshaw, he said, are there any initiatives to create and restore natural climate solutions to the vast acreage of commercial and residential properties, much of which are covered by sterile lawns? So Brendan, I'd say you probably answered that question with your project on the lumberyard. And I would say that in Massachusetts, one of the things our work group did in forming the plan is we took a first step and did some analysis and looked at potential areas for reforestation. And we defined reforestation as urban tree planting all the way up to planting trees in a riparian or other areas. And we identified, I think, about 23,000 or 25,000 acres where that planting could occur. And some of that did include lawns where trees could be planted. So that analysis has been done. And I know that Kurt Gartner from EEA is on the in the audience today, so he may want to add something in the Q&A on that. And then other questions were more related to, can people provide links to projects? So maybe it makes sense to open it up to live questions, because I didn't see, unless I missed something, I didn't see another question through the Q&A or in the chat. And I think it made sense to take those people first. So maybe we open it up to verbal questions.
And Steve, I don't know if you can hear me. My camera's not working. I did post the link. Somebody asked about the link to the proposed project map, and I assume that was the shoreline adaptation. So I did post that. And then the link is actually to the page on the CRMC website that has all the project information, including the map link. So.
I'm looking in the chat too for questions, so maybe we could just open it up, because I don't see any.
Following up on the other question about removal of the developed landscape. I mean, that's, you know, people get frustrated with all the development, and I think that, you know, that was a reason why I showed the sawmill project. Actually, the dam project prior to that was a big horseshoe manufacturing facility historically as well. So there was lots of foundations and tens of thousands of square feet of buildings that had been removed there, albeit a long time ago. The challenge with those types of things is this is, you know, private property. So from a land protection perspective for a land trust, I think the idea is, you know, be inspired or realize that you can take down a development and restore that if you have site control. Right. From the other perspective is really Steve's angle, which is, Steve mentioned, you know, smart growth. If smart growth is sort of goes the way, it's intended, you sort of move and development into community centers, then it leaves some of these places less desirable, meaning the market value for them changes, and you may be, a land trust may be able to acquire some of these properties, whether they be, old residential properties or industrial commercial properties that can be restored. Another big one, this is coastal, which I know Caitlin and I are very coastal oriented, and I don't know that the whole audience is. But the coast is a very vulnerable place in sea level rise, and beaches and access to the coast is very important for coastal communities in Rhode Island and Massachusetts. And I think that, one of the things that's threatened are these coastal access points, public coastal access points, including beach parking lots. And I think it's that's one where we change the way we need to have beach parking lots, but if we think about where to relocate them and then restore the pavement of those lots to natural coastal habitats, we actually preserve we preserve the infrastructure service that's provided for the access point, and actually restore some ecological function at those locations, whether it be wetland restoration or dune restoration or beach restoration.
I see some more Q&A questions. I think these two are directed to you, Brendan. How long did the lumberyard, how many acres was the lumberyard project? How long did it take? And what were the major stumbling blocks?
So first, how big? It's a 20-acre property. As I said, about 3.5 acres were covered with impervious surface and buildings. We purchased the property in 2007. We opened the property to the public in 2014. So that's not all doing work. The work took about two years, and it's not 2 full years. There's in-river work limitations for some of this work, so it sort of goes in sort of scheduled chunks. And then with a project like that, where you have a lot of planting to occur before it opens to the public, you have to sort of get that vegetation established before you get the public in there. So it's really about 2 years to do the restoration. The other 5 years was basically raising the money. So we bought the property, developed, we actually continued to rent out the space to tenants. That helped raise money for actually some of the cost of removing the buildings. What was the last question? Was what were the stumbling blocks?
The last was how you got the length, and then I think we're at time though, because we're supposed to wrap at 10:30, I think.
Correct.
Matt, can you hear us? Are we?
Yep.
Time to wrap it up?
Okay. Yeah, it's about 10:30 now. Although the next session is at like 10:45, I think. So if you want to leave more time for questions, I think that would be all right.
So the other question on the project is, what were the major stumbling blocks, and how did you overcome them?
So stumbling blocks is cost, and I said it took time to do that, and the way to overcome that was, the way we would normally do it is combining multiple funding sources. It's not a single funding source that paid for all of this. There's also technical challenges with doing something like that, less to do with taking the buildings down, but more to do with getting the hydrology correct, so getting the water to work correctly. And there was some revision en route. So we had actually 2 flood events during construction that helped us to improve the design of how the floodplain connection worked. That makes sense, meaning flooding occurred during construction. The site was secured, but it helped us to make some adjustments to the topography of the site so that the site could be handle more floodwater and be more resilient. Those were some of the bigger headaches.
I see 2 other questions. One I can answer, and then one for Caitlin. Afforestation credits. Those are part of the Regional Greenhouse Gas Initiative. They're designed to be offsets that emitters can purchase if they're not meeting their emissions reductions goals. And because the thresholds were pretty low for the emitters meeting their goals, there hasn't been a need to sponsor offset projects for afforestation. And then this question looks like it is for Caitlin. Why did that seem to disappear? It was about measuring the results of the sediment enhancement projects. Were you looking at habitat or water quality? What were you looking at?
Yeah, and I typed an answer, which may have been why it disappeared. But
okay, sorry.
Yeah, so we have vegetation transects where we're measuring density, species composition. We do avian point counts. We work closely with the SHARP program down at UConn. We're measuring sediment accretion with surface elevation tables and doing elevation surveys. We measure nekton, water levels. We've got water level loggers deployed. And then we've partnered with EPA who are they do shear vein measurements, soil geochemistry. I think that about covers it. And then we're experimenting with different types of aerial imagery analysis, so to try to get more landscape level change analysis. But we have used drones on both sites and done rare and native plant surveys to try to look at what is colonizing the sites versus what has been planted, and the efficacy of planting and whether that's cost effective versus just letting the site recolonize naturally. But happy to share that with anyone who's interested. We can send our monitoring plan along.
And there was a question about biomap as well. And I did see that Henry Woolsey was in the audience. He's one of the folks who helped originate biomap. So I might, if we can, if there's a way to allow him to speak, and he's still here, I would, since he's one of the primary original authors, I'd invite him to do so.
Yeah, I don't think he can speak because he's not one of the panelists.
That's too bad. Brendan, how about you? Are you able to articulate biomap?
Wait, ask your question again.
Let me go back to the question. Sorry, I got so excited seeing Henry in the audience and wanted to give him an opportunity. The question is, can you articulate on the Massachusetts biomaps? So I think this Mike Rainville just might be looking for a description.
Yeah, so the first biomap, I think, goes back to the early 2000s, developed by Nature Conservancy with Massachusetts Natural Heritage and Endangered Species Program. The idea was when it was first developed, the first biomap very much oriented towards rare species and biodiversity, but evolved to biomap 2 to much more than that. It still includes protected species, but really a lot of sort of large forest blocks, and where, if lands were protected, ecological functions and biodiversity could be best preserved in Massachusetts. Going back to those early days, I always thought of this as a real a great success for Massachusetts. They were really sort of a step ahead of some other states. I remember when I was involved in the National Estuarine Research Reserve System, sort of sharing sort of the benefits of that with the other coastal states. But the point being is, it's not. I was showing it for coastal. It's for the entire state of Massachusetts. You can Google it and play around with it, and then you can, if you want, you can upload all the data layers to your GIS. But basically, it's showing the land areas in Massachusetts, regardless of ownership or anything, or even if it's already protected land, the areas that are most important to protecting biodiversity and ecological function of the landscape.
And I'll offer a friendly amendment. Biomap is now being updated, and it's including the resilient lands work that looks at land and water resources that are better positioned to withstand the impacts of climate change. So the way our lead scientist, Mark Anderson, describes it is, we're preserving the stage because the actors will continually change during climate adaptation when species are migrating.